Okay, hello everybody, welcome to my presentation today. Main theme of the presentation is big data, which is probably no surprise to you guys. So my name is Pat Pruchnickyj, I work for Talend. Talend is a company that provides technology for integrating systems, applications and data. So you might want to think of it as middleware or glue that sticks applications together. And one common source of data these days that's being considered by most companies is big data. So this presentation really talks about big data in some concepts. It would be helpful for me to know where you guys are in big data. Is big data new to you? Have you got some experience with big data? Are you still trying to figure out what it means? Is there anybody in this room that is, big data is completely new? Would you? Right, okay, we have got people that, are there any people in this room that have got projects underway with big data, whether they're in production or, right, okay, so I've got a mixture. So I hope you appreciate then that when I talk, I have to sort of give the basics, but also talk to the experts in the room, all right? So that's unfortunate in any type of presentation, but I will have to try and consider the mixed messages. Right, my role at Talend, I'm Director of Product Marketing for some of our products. Talend has roughly 6 products if you categorize them into the different domains that they support. Big data being one of those 6. So I look after enterprise service bus, business process management, and what we would call service-oriented architecture. And big data is starting to come into that mix now more and more in many of our clients. So I've got a few things to say about big data. Anyway, so that's me. We'll talk about the next 5 big killer apps, and we'll also talk about what a killer app is for big data. So first of all, I just want to introduce you to Talend, as you may or may not have heard of Talend before. Talend started in 2005. We're a vendor of open source technologies. What that means is that we use open source projects and package those together to make them available to people that have a need for them. To date, we've had about 1 million downloads of our technology from our website that people use either for their own personal needs or in their companies, or they use it for some form of business within their companies. But Talend's in business to make money, right? So we don't only do open source for free use by anybody that wants it. Today we have about 4,000 paying customers. Why customers buy product from us is because whilst they use the open source technologies, if you're in a team development environment where you've got multiple users all trying to share the same artifacts or put those artifacts into a single runtime environment and manage and monitor and optimize the way that code is running, then they come to us for commercial versions of our products. So we license them under a subscription. And that means you pay for the period of time that you want to use that software, and we provide you with support. So there are features that we provide commercially that aren't available in the open source version. Everything that you want to do, you can do in open source, but if you want 7 developers sharing a single repository, then you need to buy something from us, right? And we give you that extra development productivity by using our tools that way. So like I said, we've got about 1 million people have downloaded the product, 4,000 paying customers. The other stats on there, well, what can I say about that? 50 new customers a month. I mean, it's a growing company. Our revenues are growing roughly 100% per annum since the last 5 years or so. So although we're only 450 employees today, we are growing. We're hiring people all the time. So Talend is uniquely positioned in the marketplace because we have the large community of people that use our technology and provide information to us about how they want to use that product in the future. And that differentiates us a bit from commercial vendors who are really only interested in making money out of their customers. We're interested in innovation and technology and how to make best use of that technology. So that's Talend in overview. We do have a stand, by the way, here in the exhibition. As you go into the hall, we're the first on the right. So if you want to come and talk to us about what your projects are, how you think you might be able to use Talend, then by all means do that. I'll be there all day. Now then, I want to talk a bit about big data, but before I do that, I want to just sort of position really where most companies are in terms of their IT landscape, because we have evolved our IT over many years. Most companies aren't starting today saying, well, let's build some IT systems. They've been using IT within their companies for 20, 30 years. right? I mean, unless you're in a startup organisation. I mean, is there anybody in here that's company's been around less than 10 years? No. So you're all companies that have been around for more than 10 years. So your IT infrastructure would look something like this, okay? Now, there's one thing that I would ask you about this, and that would be, how would you describe this? If you were asked, if your first day on the job was to look at the IT and see how you could optimize it, you'd look at that and say, yes, that's complex. So I think if I asked you what you thought about that, you would say it was complex. It's not a problem that our IT infrastructure is complex if it's supporting the business today and in the future. The problem is, most companies are in a very competitive marketplace, and the only way they survive in business is to evolve their offering to their customers. And that usually requires changes to the IT infrastructure, which has over the years evolved to look like this. It's become brittle and fragile. It doesn't adapt easily to changes in the business. Now, we don't represent our IT like this really today in organisations. This is probably a picture from probably 5 years ago. Most organisations have adopted a way of thinking about their IT, and they look at it more like this. And this is what we would call service-oriented architecture. It's really a way of understanding your IT systems, where you have been able to, if you like, service enable the key functionality in your core applications. So if you've got applications like customer relationship management, enterprise resource planning, you may have a logistics application, a warehousing system. All these systems get connected together through services that we would then access from a higher level function. So maybe you've got process management in your business, and it accesses the underlying infrastructure using these service calls. So you can adapt your system to look more like this. Now, functionality is the same. It's just an easier way to change and to adapt to new business requirements by using an infrastructure that looks something like this. Now, big data can just be another source in this particular architecture. But what's happening is people are now also looking at how do they use cloud within their organization. So I would hazard a guess that most companies, most of you here today, have got some activities that are using either infrastructure in the cloud or applications in the cloud, or some cloud-based business requirement that you're investigating. And the reasons people adopt cloud are manyfold, and we'll talk about some of those in a minute. But before I get to that, what I wanted to say is that when we look at why people are adopting cloud as part of their overall IT infrastructure these days, they have forgotten that some of the things that we did to streamline and optimize our IT infrastructure on premises, we shouldn't forget when we go out to look at the cloud as a way of running and optimizing our IT infrastructure. We mustn't forget that the services infrastructure that we created is valuable not only on premises but also in the cloud. What we had done when we created that agile IT infrastructure is we stopped thinking of our IT systems as silos where we have CRM on its own and ERP on its own. We tended to use things like canonical data structures where we could then talk about the entities within our business like customer. And the customer entity might be in an ERP system and a CRM system, but we think of our data in that way. We've broken down the silos and we've accessed these information sources through services. We also, at the same time as putting all those service infrastructure layers in the business, we cleaned the data and we put some governance over the data. And all of these things happened in our IT infrastructure. So now if we're moving to the cloud as a way of evolving our IT, then one thing that we want to be able to consider is that we don't want to forget the lessons of the past. We've learned how to optimize our IT infrastructure internally for agility, reuse, and responsiveness to the business. If we move to the cloud, we want to be able to do the same thing. Now, for me, when I think of big data and I think of cloud and I think of service-oriented architecture, I think of these three things coming together. And so if you're talking about big data, if you're talking about cloud and you're talking about service-oriented architecture, I think all of those topics overlay slightly with each other. And so it's worth understanding how all of those play together in a final solution. Now then, In the concept of big data, I've got a few statistics here that we've gathered from our own internal research and some others, and these are worth looking at as well. If we ask people, do you have an effective information strategy in place? 59% of people say that they don't. So that's a bit worrying. If we start talking about how we optimize the use of our information and our business systems, but we don't really understand how we're going to have a strategy around data, then I think that's a big problem for us. So most companies, if you ask them today, are still struggling to get the basics right. I mean, when I think of integration, I think of data integration as being the first thing most people tackle. And then they think about, well, let's do some application integration because we can preserve referential integrity between systems by using an API between the systems rather than just moving data on bulk from one system to another. So it's worrying that there are still companies out there that are struggling with that. Even worse, 98% can't deliver the right information for the right reasons at the right time to the right people. Most IT directors will still say, I've got a problem getting the right information to the right part of the business at the right time. So this is another big problem for us. So we still have a quality issue with data. 48%, that's nearly half of the people, said that data quality and managing unstructured data is challenging to existing practices and tools. So although we've got IT infrastructure that's been designed to support quality of data, movement of data between systems, most people are still struggling with the overall quality of unstructured data within the business. And 52%, this is again half of the people, so that they don't have sufficient resources in order to manage the new technologies that they have within the business. In fact, I spoke with a customer of ours on Monday, and he was telling me one of the reasons why they selected Talend, and it was because they had a large array of data integration projects that they were working on, and they also had a large number of real-time integration projects that they were working on. And he said every other vendor that they looked at, they would have to buy 2 different products and do 2 sets of trainings for each of the individuals, because the individuals were required, limited resources were required to do work in each of these project areas, and yet they would need to learn multiple tool sets, whereas with Talend there was only a single product that they needed to learn. So for them that was a huge saving. They couldn't quantify how much it was, but it was a very, very significant value to them. Now when we talk about big data, and I know I've asked in this room already, big data, who's doing it? And I had a couple of hands shown, right? We crudely talk about this as like it's the schoolboy sex syndrome. At class you say, oh, you doing sex? Well, yeah. Everybody thinks they're doing it, and they talk to their friends about, yeah, we're doing it. But actually when you really ask them, when you really understand it, you find that, well, actually they're thinking about it, or they're talking about it, but they're not actually really doing it. So it's still a bit of a grey area, if you like. People are assuming that every other company that they come into contact with is doing something real with big data. I think the real picture is about big data is most organisations are thinking about it. Some companies are actually researching it or dabbling with it, but there are very few real use cases where companies could actually stand up and say, we've saved X by using big data, or we've made huge growth in our business in this area by using big data. Now there are many, many different stories and discussions going on about how big data can how you can take advantage of the information from big data within your business. And I sort of hypothesize about a few of those myself when I've got time, but really very few companies are doing it. I mean, unless anybody in this room wants to tell me, yes, we've saved money with big data, or we're doing more business with big data, I'd be happy to hear the use case. So don't panic about it. Not everybody's doing it, and there are very good reasons why. Going back to this cloud theme again, people are thinking of the cloud, and I just wanted to highlight some key reasons why people are adapting use of cloud within their businesses. Now, if you're a very small company, you might use the cloud purely because, well, you don't want to have to manage your own IT infrastructure just to have, oh, I don't know, your customer data being managed by an application, and you might go to salesforce.com or some other software as a service supplier to do that for you. And it makes sense to do that because you don't have the IT support, you don't have the systems knowledge, you're a small company, you want to do that. But of course when you do that, you give everything to a vendor, and everything that you get is from that vendor. So providing what the vendor offers is what you need, there's a good match, right? But bigger companies have a more complex business model. They have a wider range of needs, and they typically go to the cloud for other reasons. One of the main reasons is that it's elastic, it's scalable. They can switch it on and off whenever they want. So if they want to test a project, like a big data project, they can rent space, CPU, if you like, and storage in the cloud and put all of their information into that system, run it for a few weeks and say, nah, that didn't work. They don't have to then sell the hardware off to somebody else at a loss. They can just turn off the subscription. So people buy the cloud for many reasons. So it's elastic, it's scalable, it's easy to use, it's easy to deploy, and the cost model is more on operational expense rather than capital expense. And so for some business models that makes sense, right? So people adopt the cloud for very good reasons, and these are some of them. But people are also fearful of using the cloud for very similar reasons, okay? How do you get the data from your on-premises systems into the cloud, or how do you load the cloud in the first place? That requires technology, it requires skills. Is my data more secure in the cloud or more secure on-premises? Well, that varies by organisation, and in most cases, actually the security experts at the cloud vendors will probably claim that their security is greater than your own on-premises security, because you don't really have that much expertise in your business to do that. So, there's always an argument at both sides of these points. Lack of control, well, yes, if you put in all of your data into a software as a service application, you don't control the application, but is that really a problem for you? Probably not. Lack of skills, it's usually a lack of knowledge rather than a lack of skills that keeps people away. And then they might not know what the costs are, only because they haven't looked at the model. So for every one of these is a counter argument. But don't take my word for it. This is an interesting survey that's accessible publicly from KPMG. If you go to their website, KPMG/cloud, you should probably find this survey. It was conducted at the end of 2012, published in January. It's quite an interesting survey, but what it talks about really are the two challenges that come to the top of that. Implementation, transition, integration costs are too high, and integration with existing architecture. Those are the top two challenges that people were saying is the reasons why they don't adopt cloud today. Which is interesting, because we think we actually have an answer to both of those top two challenges. So if you're thinking about moving information, data, processing to the cloud, then I think you'll find that Talend can really help you with that. Okay, so if you're doing big data, first thing you need to do is you need data, right? So data. There's no shortage of it. Just wanted you to be aware of that. We're not actually cutting back on the amount of data that we use within our businesses. We're actually using more data. Any of you with a smartphone, you're probably appreciative of just how much data you consume, because you probably get an invoice for it from your telco provider every month telling you how much data you've used. Your business is constantly buying more storage, constantly increasing the bandwidth between offices so that you can communicate with your colleagues via email or whatever. Now, I accept that this is quite an old report, but the picture's the same whichever report you look at about potential growth in the data storage, data transmission, network bandwidth, personal use of data. It's growing, and it's growing exponentially. It's a huge amount of data that we're processing. This is why big data becomes a solution to some business problems. But okay, so if you accept that data volumes are growing, that's one thing. If you're going to process this data in any form, then you're going to need some computing power to do that. And computing power comes in many different forms. You may remember, for those of you that go back as long as I do into the IT world, that we used to have these things called crays that in fact, I used to work in the oil business, and I remember in the computer room that I used to work in, we had a cray, and it was one of these nice ones with the seat around the base. You may have seen pictures of it, look at it on Wikipedia or something, but we used to go and sit on this because it was quite cool to do that. And I was only a young lad at the time. But anyway, these things were expensive. They cost millions and millions of dollars, and you had an army of people to process the data that went into them and to manage the results that came out of them. big expensive. Now, what we've got on the right is an alternative way of processing large volumes of data. And this is using cheap, commodity, inexpensive, standard PCs or standard Linux boxes or whatever. It's just cheap hardware. And if one fails, it doesn't really matter because it doesn't affect the operation of the rest of the work that's being processed by that group of machines. Call it a cluster, call it what you want. So the good news for big data experts is that this is now the new norm. This is the way we process data. Not on the left with the expensive, I've got a budget for this for 3 years before I can afford it. I can just go to my local PC reseller and buy some second-hand machines, stick them in a server room somewhere and plug them all in. And if 3 of them don't work, I don't really care because I didn't need them all anyway. And now, the theme of the presentation was about killer apps. I don't know if you know what a killer app is. I thought I should tell you because maybe you aren't aware of what a killer app is. A killer app is one of those things that is so fundamental to the way people are thinking and processing and working that it's driving the sale of something else, right? So in the context of a killer app, the phrase came out a long time ago, but it was first used in the computing world when VisiCalc was made available for Apple II hardware. Because at that point, Apple II computers, I mean these are very early personal computers if you like, were available and they were mainly bought by the geeky programmer types that like to mess around with computers and show off to their friends how clever they were at writing software. But then VisiCalc came out, which is a really useful tool if you're an accountant because it can do really neat calculations. We've all used a spreadsheet. We know the power of a spreadsheet. VisiCalc came out and all of a sudden Apple II hardware sales went through the roof. And it was that one application that drove the sale of the hardware that made that product so successful. Okay, so you could argue without VisiCalc, Apple II would never have grown. Where would that have taken us? I don't know. But anyway, so that's what a killer app is. It's something which on its own is driving the business in another way. All right. So there are already things happening in the big data world that are driving sales of software and systems because of a need to do something. And we have 2 types of application here that are already very significantly growing because of people's need to understand information from big data. And so we've got analytics, and if you go to the exhibition hall, I'm sure you'll see analytics vendors out there because they are around big data all the time. And then the need to load the cluster with the data in the first place to process it. So these are already very well established as killer apps in their own right, if you like, because without them you couldn't really use big data. You don't put big data into a big cluster farm for the purposes of storing the data. You put it in there because you want to get information from it. So analytics and loading that are the 2 key things that are already well established in the big data world today. Okay, so what are the next 5? And here's the list. And we're going to go through each of these in just an overview really, just sort of touch on the subject so you can understand the concepts behind them. So we've got extract, load and transform. You may have heard of ETL, extract, transform and load, and I'll talk about the 2 differences between those. Profiling of data, parsing and standardizing on data, matching and survivorship. So this is where you're trying to understand, well, okay, I've got multiple records, but they all look very similar, so which is the truth? Or maybe none of them are the truth, but maybe the combination of those is the truth. And then, enrichment around things, around master data management, which we'll talk about. So these are the sort of the 5 areas that, if you don't have these, you can't really make much use of big data. You need these to really take big data to the next stage. So you've bought your commodity hardware, you've put it into a room somewhere in your office, or you've bought some space in the cloud, and you need to now load the cluster with information so that you can do something with it. By the way, I know some of you are sort of carefully taking notes or taking pictures of the slides. The slides are available on our stand on a memory stick if you want to come and collect it. All right. So, I believe they were loaded. I didn't do it myself. My colleague did it on Monday in the office. So, but if they're not there, my business card's here. Email me and I can send you the slides. All right. So, just to make life easier for you guys. Right. Oh, sorry. I'll go back a minute. Right. How do you plan to load this data? Now, There are some people in this room that don't know too much about big data because they put their hands up when I asked. All right, so for those of you that do know about big data, please bear with me because I just think it's very important that we understand what big data is. I get asked a lot by people that come to our stands or people I meet that say, oh, you know something about big data. They ask me, what is big data? And I learned this 18 months ago. And I think it's a very good way of describing big data. It's not my definition, but it's the 3 V's. So if you don't remember anything else from this presentation other than the 3 V's, then you'll be better off, right? Volume, variety, and velocity. Right? I know that doesn't say that on there, right? Volume, variety, and velocity. So what does that mean? It means you've got a lot of it, volume. Variety, many different types. Okay, so both structured and unstructured. And the velocity is the speed at which it's arriving at you. So if you're taking feeds, just imagine in your business, you're taking feeds from Facebook and you want to filter that data to find out if anybody's tweeting or, not on Facebook, they don't tweet, right? From Twitter feeds or Facebook. And they're mentioning things about your company, good or bad. If you were looking for that, how much data do you think you'd be getting every minute? Probably a lot, right? Okay, so what makes big data is not the volume, not the variety, and not the velocity. It's a combination of those factors, and whether it's 2 or 3 of those, or even just one of those, doesn't matter. The fact is, it's one of those things that characterizes big data. Okay, so you may have lots and lots of data, but if it's very well structured and ordered and stored in your relational database, that's not big data, right? Because it doesn't have the variety, and it's not coming at you at lightning speed, all right? Now, you may have the variety and the velocity, but you don't have much of it. It's still big data because of the way you're going to process it, all right? If you're not sure, come and see me afterwards. Right, and this bit at the bottom, right, your data might not come to you as cleanly as you might like. The information about your customers, because it was typed in by somebody on Facebook, might not be correctly spelt. So it might be more difficult than you imagine to try and match that with an individual customer record in your systems. So you always have a quality issue. So I said I'd mention extract, load and transform and compare it with ETL, and this is really my slide on doing that. Okay, so classically what we would do is, and this has been around for many, many years, extract, transform and load. And what you do here is you run a process which extracts loads of data from multiple sources, and then it transforms it. It does some processing on it, which, you know, I don't know, it might normalize it, it might denormalize it, it might cleanse it, it might do many things to the data, and then you load it into something like a data warehouse where you can do analytics on it, business intelligence. So that's called extract, transform, load. Get loads of data, do something with it to clean it up or whatever, and then load it. Now, in that scenario, there's 2 places where you're doing the processing. In the extraction, in the transformation, and then you're loading it. Okay, now then, remember we've just gone out and bought loads of commodity hardware, and we want to use this to run our big data jobs on, right? So a smarter move is to extract it from wherever you're extracting it from, then load it into the big data cluster, into Hadoop, and then do the transformation. Okay, because the processing power of the cluster is far bigger, better, more powerful, more capable than the engine that you're using for the extraction. Okay, so really what you're doing here is you're just moving the work to a different place and doing it at a different time. So you're taking the power of the cluster to the job, right? So extract, load and transform is the first killer app. You know, this is the thing that people will be doing. So if you did ETL in the past, when you start doing big data, you'll really be thinking of ELT rather than ETL. All right? Hope that makes sense. 2, data compliance never goes away. So how do you identify anomalies in big data and the enterprise? Okay, so this is really the other thing. And you need good quality data. If you're going to do anything that you're going to make business decisions on with the information that you've got, then you really need to be able to have trust in the data. Okay? And I think trust and provenance and governance and all these phrases come out when you start to think about, well, where did this data come from and what can I do with it? So you need to make sure that you're compliant with Data Protection Act. You're not using. In fact, I spoke to somebody. It was in a public sector show a couple of weeks ago, and he was telling me, local council in Scotland, and he was telling me that if somebody reports a problem with a pothole in their road, that person also has maybe a record of the council tax. Okay, so we have information about him, his name, from two different sources. His name is the same in the council tax record as in the record for the reporting of a pothole. Now, if they wanted to contact him because the information that he gave about the pothole, let's say he didn't have his phone number in it, but we've got his phone number from the council tax record. If they actually join that record together, they're breaking rules to do with the Data Protection Act because they're not allowed to use the data for a purpose other than what it was provided for. So if his council tax record was provided information so that they could manage his council tax, they can't then use that information to contact him over the pothole that he's reported. All right? So there are rules around this. And of course, if you want to implement these rules, you need to really understand that the data's clean, what the purpose was for it being stored. And in the last time I gave this presentation, we had a long debate in the room from one of the guys who was really quite vehement towards me about, well, you can't just take information from Facebook and do stuff with it, which may or may not be true depending which jurisdiction you're working in, but it is an issue. Okay, but anyway, we have the need, if you like, in our business to be able to understand the quality of the data, profile it, and do something with it and store it in an appropriate way. Okay, so without this capability, you can't really trust the information that you're using within your business. So profiling the data is going to be a big requirement for most people. Now, when we talk about velocity, variety, and volume, we start to talk about the variety side of it. Now, in traditional transactional-based systems, we typically had a customer record and a product record, and we understood those from the concept of that. So in the unstructured world, information that people have written in an email or who uses Gmail, Google Mail, right? Okay, it's worrying when you type an email to a friend and then all of a sudden you get, I sent some email to a friend about babies or something at one point, I can't remember what the concept was, and I'll start to see all these adverts for baby clothes in my Gmail. Somebody has looked at my unstructured sentence and made an assumption about what my interests are and provided me with adverts to help me buy products in an area that maybe they thought I was interested in. Okay, this unstructured data needs to be processed if it's going to be understood. And unstructured data comes from a number of different sources. So for example, as a business, you might be interested to know which pages people visit on your website. And they may have sent emails to your customer representatives. And you might want to match the email questions with the visit to the website so that maybe you could infer what it was that they were trying to understand about your business or your products. And then you might match that with things that they'd commented about your company because they mentioned your name in a tweet or on a Facebook page. Okay, and you need to bring this together. So somehow you need to be able to parse this data to look for these strings, things that you want to do to understand the value of that information. So, do you have matching requirements that could be better served by scalable matching? And what we mean by this is customers come in many shapes and forms, but they usually have some form of identity. And most often when they talk to you, they don't talk to you about my customer ID is XYZ. They normally say, oh, my name's Fred Jones. Okay, Fred. Now, maybe that's in your system as Frederick Jones. Or maybe he changed his address recently and you want to send him some goods, but you don't really know which address to send it to because you can see that the address data was quite old in your systems. So matching and surviving that information, if you're going to make business decisions on it, becomes another critical requirement for your big data projects. So somehow you need to manage the whole governance of information sources, the quality of the data, and then how do I create this sort of golden record, as it were, of information that I want to be able to use against that particular business person. And of course, if you've got variety, velocity and volume of data coming at you for this, then the processing that you're going to have to do against this becomes a very large amount of work. So it becomes bigger all the time. The processing becomes bigger. And all of those things come down to master data management, which is a sort of a discipline around governance of data, governance of information. And we're now thinking about this in the big data sense. Now, there's a really interesting use case that is worth talking about here, because it does highlight some of the things that I've talked about in the previous few points, and also it brings together some of the other discussions that I've raised about the council in Scotland, for example. And I don't know if you know a company in the US called Target. Maybe if you've travelled to the US, you've probably seen them. Okay, they're a retailer. Okay, don't get into too much detail about them, but they sell products and have a loyalty card. Now that means if you're a customer of theirs and you've got a loyalty card, your purchasing profile and history is understood by the business. So when you go to the checkout, give you a loyalty card, there's a till receipt which has got products itemised on it, and so they know what you're buying. Now if you imagine you're pregnant, that's for the females in the audience, right? And you're buying products for a potential future birth that you're going to have, then there are certain products that are going to appear in your shopping list that you didn't buy before and you might not buy afterwards. So there's a window of opportunity to sell you add-on products that might help you with your pending arrival, right? So if you're a marketing executive and you've got that information, what are you going to do with it? You might now target that individual with some special offers. Now, this isn't a true story, but it's a true discussion that took place where the CIO of Target was at a press conference and he was talking about what they were doing with big data and how they were going to use it in a business context. And it was suggested to this CIO during the press conference that they had in fact sent an offer to a 16-year-old girl who was buying these products for a future pregnancy, but the letter was arriving at her parents' house and was opened by her father with these offers for baby carriages and, oh, I don't know, baby bottles and diapers and nappies, right? Okay, now you can imagine what a problem that would cause for this particular customer. It wouldn't be a very good situation to be in. It wasn't a true story. It was just something that the journalist had put at this CIO to see if there was some way that he could find a solution to that particular problem. But it does mean if you're using this information in your business, you have to be very careful about how you use it. The other really... Sorry.
That point there, I mean, the example you just cited there, the Target, the actual retailer,
yeah.
Is that a true case, an example of big data?
It is.
Someone like Tesco,
yeah.
their club card, their scheme, which was a
yeah.
pre-data paradigm change, they were doing that with their existing context
yeah.
through the club card
yeah.
scheme and marketing stuff like that. So is that not?
Okay, so I don't know if you can all hear that from the back, but the question was, well, but Tesco were doing this sort of thing with their club card scheme before, so is it really big data? Well, it's only big data if they've got these other V's in it. Like if with club card, it's all structured data, and it's not coming at them at lightning speed. And to be honest, they don't really have that much data in terms of their customer records and till transactions. If you added into that something like Facebook and Twitter feeds, right? Then it becomes big data, all right? Now, with Target, they are able to understand the profile of their customers outside of the Target domain. So where else do they go shopping? Which other towns do they visit? They can buy data from credit card companies, from Facebook, from Twitter, and they can build a profile of that customer to get a much better understanding of what they're doing so that they can be more specific in their targeting of marketing messages to that individual. Yeah. Anyway, so whether it's true or not, it just really is a good case study because it gets you thinking about some of the challenges that you're going to face and some of the opportunities that exist in the marketplace. But all of this requires, being able to access the data, being able to process the data, and being able to trust the data. Okay, so for all of these things, there are things that you need to consider. And I've tried to summarize them there on this slide. So for extract, load and transform, what we're suggesting is that you do the transformation actually in the cluster because it's a much more powerful engine to do that type of processing in. Profiling, again, use the power of the cluster. If you've got the data, load it in, then profile it. Parsing and standardizing, it's the same thing. You know, you don't necessarily have to parse all of the data, you're only looking for certain keywords. You know, the way the Hadoop cluster works with MapReduce is a very powerful way of doing that. Survivorship, again, processing in the cluster. And finally, master data management. Again, large volumes of data, put it in the cluster, work out how to process that data in the cluster. It's the way to do it. So all of these are talking about use the cluster for effective use. Now, there's just a very simple comparison here made by one of our clients in, it was a benchmark that they did because they were just interested to see what the difference was between doing extract, transform and load and extract, load and transform. And what they're showing here, sorry, there's only the summary bit of it is this was the original job that they had where they did extract, transform and load. And they were showing in minutes how long it took to process different data sets. And you know, we've got 360 minutes here for the largest one. But if you then use the Talend product that we've got for big data to do a similar task, the numbers on the right are, you know, showing, you know, roughly 10 times improvement in performance for doing it that particular way. So that's just a highlight of one of the you know, case studies that we've got on that. This was done by one of our customers in America. It's a big financial institution. What I wanted to do is to just sort of talk to you very briefly about the offering that we've got for big data. There are two enterprise class products. One is really just focused on, I'm only doing big data, and one is focused on, I'm doing big data, but I've got other things that I want to do with that information. These are both commercial products, but we also have a free download of the Talend Open Studio for big data. So if you wanted to experiment with it, play with it, do that. It actually gets distributed with one of the distributions that we support, which is the Hortonworks distribution. I don't know why I haven't got the Hortonworks logo on there, which I thought I did have. But anyway, so if you downloaded Hortonworks, which is one of the big data distributions for Hadoop, then Talend is embedded in that. So, or you can go and get the Talend big data product, which is an open source product from our website, and it's certified and tested with these different big data technologies. When you use it, you basically end up with a graphical studio where you can design the jobs that you want to run and either run them locally on your machine, or you can press a button and it will deploy that code to the cluster. So you're not having to write code, you're basically describing the job graphically, and we load the code into the cluster and it runs natively in the cluster. We don't deploy components in the cluster. We don't have a runtime engine in the cluster. We use the native MapReduce code on the cluster, or the pig script, or whatever else it is that you choose to use. That's what we do. So if you want to go to our website, you can find out about our products in a number of different ways for big data. And that's really what I wanted to say about our presentation today. I don't know what the time is. Oh, it is actually lunchtime. I have got time for questions either in the group here, or privately here, or on the stand. And I'm here for the rest of the day. My business card's up here if you want to take a copy of it. So thank you very much. Thank you.